Right, okay, so we're now going to move it on and we're going to look at similar area. So the key difference here is just that we're now dealing with area and we're no longer dealing with finding missing sides. And you'll see that we've got two triangles, but in this example we're actually given the area of the smaller triangle and we're being asked to find the area of the bigger triangle. The maths we've done so far is going to help us out a lot with this. It's very similar, there's just one slight change. So again, we start off in the same way. So what we're trying to work out, is it an enlargement or is it a reduction? And again, if we look at this, I've got the area and the base of the smaller triangle. I'm being asked for the area of the bigger triangle, so it's an enlargement scale factor. So again, I'll just write that down. Big over small for the enlargement scale factor, so I've got 7.5 over 5. Now, if it was just another line that I was finding, or another side I was finding on the triangle, then that would be all to do with the enlargement scale factor, but it's not, it's an area. And if you think about how area works, when you are finding an area, you multiply together two dimensions, okay, length times breadth for the area of a rectangle, a half base times height for the area of a triangle. And if you think about your units as well, it's squared, so you can see there that the area of that smaller triangle is centimetres squared. If your area was in millimetres squared, metres squared. And that's a kind of clue as to what we're going to have to do with the enlargement or the reduction scale factor to find out missing areas. We're actually going to have to square it. So we take this fraction and we square the full thing, and we make sure that everything inside that bracket is squared. And I'll show you actually how to put that into your calculator so you don't make any silly errors. Okay, so once we've got the enlargement scale factor, it's the exact same thing. The area that we're looking for is going to be the enlargement scale factor, 7.5 over 5 squared, times the smaller area to get us the bigger area. Okay, I'll grab a calculator. Okay, so how I would do this in my calculator, you can actually put this on all at once if you have a kind of decent enough calculator. So you can use 7.5 and your fractions button over 5, put that inside brackets and then just square the full bracket, times by 24, and you'll get your answer. You don't have to do it that way. Remember, 7.5 over 5 is the same as 7.5 divided by 5. Get your answer to that, which is going to give you 1.5, and then square your answer, and again getting your answer to that, which is 2.25. Taking that number and then multiplying it by 24. Okay, so we're getting 54, and we are dealing with an area here, so it's centimetres squared. And again, that ties in with the diagram. We would expect the area of the bigger triangle to be bigger, which is, okay. And you would apply the exact same technique if it was a reduction scale factor. So if I was dealing with a reduction scale factor, it would just be small over big, squaring your reduction scale factor and then multiplying whatever the bigger area was to get your small area.